Okay, so this is our third session of our 4 sessions, our kind of like general review and recap. Based on the ideas from last session and what we kind of discussed, it seems like the way forward is to essentially just look at a lot of past paper questions. A lot of people are still a little bit worried about the bigger kind of 4 to 6 mark questions. There was a few of these like relating to area, volume, kind of density questions were mentioned as well. So what we're going to do, we're going to start by looking at some angle theory. Again, this is a topic that you have our main topics like percentages, fractions, ratio, area, statistics and averages. There will always be a question on these, potentially 2 of them, because you might get one on the non-calculator, one on the calculator, but these will always pop up. There's the other questions which don't pop up every time. So that's things like we're about to look at, so angle theory and things like this. So because of that, we don't cover it specifically when we do our 10-week course. There are resources for all of this on the Google Classroom, so do please go and have a look. There are full recordings of everything and assessments there. But I just thought it's always good to know exactly what might pop up. So we're going to have a bit of a look at some angle questions and some plans and nets. And then we're just looking at past paper questions and just seeing how we do with them, seeing how we work them out. Okay, so for this session in particular, we're going to have a look and work out, well, what are plans for starters? Then we're going to look at plans and nets and the links between these. Exam style questions on these 2 topics. So this is for level 1 and level 2 learners. Then we're going to have a little bit of a look at our angle theory. So this is relating to quadrilaterals, triangles, straight lines and parallel lines. I have put some diagrams and things in which can look a little bit confusing. But in reality, they're not actually too bad. We don't need to know absolutely everything. You'll see that when we look at the exam style questions. It's just knowing the basics will get us through. And then we've got our exam style questions. Okay, so if we're talking about plans then, in functional skills, we might be asked to draw plans and elevations of various shapes. You won't ever be asked to draw a 3D shape, so don't worry about your artistic skills. In order, I have seen them ask for a sketch, potentially. I saw on a recent paper, they asked for a sketch of like a cylinder. But that's as far as it goes, you know, doing a little sketch and drawing the, like maybe the, like the measurements on there. But you don't have to draw, given the dimensions, you don't have to draw a 3D shape using like isometric paper, for instance. So you don't have to worry about that. So in general, what we're dealing with then, if we have a question like this, for instance, we just need to know what all of the different views are. So when we're drawing, or when we're talking about plans and elevations, it's always the idea of looking at a 3D shape and drawing the different angles of it in 2 dimensions so that you can then essentially piece it together and see or know what the 3D shape itself is going to be. So the plan view is the view looking down on the shape. So normally in English, we would call this like the bird's eye view. But for us in particular, they'll always refer to it as a plan view. So it's just looking from above and looking down at what's happening there. We then have the normal kind of like elevation. So, you know, we have like the front elevation, the side elevation, the other side. The main one that tends to throw people is, you know, if it says, you know, what is the plan view of this object? If you don't know what plan view means, then you can't get the marks. So now that we've covered that, you should be absolutely fine. So it's just an idea, and again, you won't have to actually draw any 3-dimensional shapes, but it's just an idea to kind of show you how you can look at these and obviously work out what the 3D shape is going to be. So we've got these 3 kind of images down the side here. So I can see what this shape will look like from the front if I look here. So I can see that there are kind of 2 squares and it's 4 squares along. So I can kind of see that that is the type of shape that it's going to look like. If I look at it from the side, it looks like this. And if I look at it from the plan view, it looks like this. So if you kind of think about what it's actually going to look like, if I kind of draw the, you know, the front looking face on here, so it looks like this. So that's from the front. If I then look from the side, then I can kind of tell that it's 2 squares here and 2 squares here. So I know it's 2 squares long and it's got 2 squares on top. And then I can just fill in the gaps there. So when I actually look at this from the plan view, so between those 3 angles, it tells me exactly what the 3-dimensional shape is. So if I'm looking from the top, it just looks like 4 squares and 4 squares. I can't tell the depth of it because I'm only looking at that angle. So I can tell like the width and the height, but that's it. I can't tell how far down that shape goes. That's why I need the front or the side as well. There have been some questions where they've mixed these kind of questions in. So they might give you a drawing of the side view and the plan view maybe, and then ask you to draw the front view, something like this. So another quick example here then. So again, if I'm looking from the front, it looks like, well, I don't know how to describe that shape really. It's 3 long and it's got these kind of higher bits at the side as well. But it's definitely 3 along there. I can't tell where they are though. I don't know if they're on the front kind of square, if they're on one further back, for instance. All I know is that it's 3 squares long and there are 2 squares higher up. So that's why, again, I need to use the other kind of like the other dimensions to help me work out what this shape is going to be. So using the side view, I can tell that it is looking like this. So obviously this is really helping. And then when I finally look at the plan view, that's going to tell me where the other pieces all fit in. So the shape we end up with is something like this. So in regards to the actual questions that you might come up against and what they actually look like, we have a question like this. We've got a diagram shows a prism. And do remember that the word prism can cause a bit of confusion sometimes. All of the 3-dimensional shapes that we deal with in functional skills are called prisms. A prism is just a 3-dimensional shape that maintains the same shape over its distance or over its depth. So if it is a triangular prism, it is a triangle that then extends. If it is a rectangular prism, it's a rectangle that then just extends. They use the word prism because it informs us that we can actually, so long as we work out the one area or the area of the face, we can then just multiply by the depth, and we can do that with any prism and it will work. So if we've got an idea here. So let's say, this gentleman here is looking at this shape and he wants to know, well, which of the diagrams are the correct, or is the correct one for the prism above? So we've got these options here. So they've drawn the little guy on there again, just to kind of show you where the front elevation would be. So hopefully you're quite happy with this. If I was looking at the plan here, so I imagine I'm looking from the top down, what am I going to see? So all I'm really going to see here, because I can't tell that it's 4 centimeters high at all. If I'm looking down on it, I can't even tell the slope there as well. So I can't tell that it's that, that 5 centimeter long slope there. All I'm going to see is a rectangle that is 3 centimeters by 6 centimeters. If I'm looking from the top, that's all I'm going to see. And this is a very common type of question they might ask. More common on level 1 papers. They tend to favor asking about kind of angles a little bit more when we get to level 2. But that's all I'm going to see there. So if I'm looking at the front, then what am I going to see? Well, in this case, I'm going to see a rectangle again, and it's going to be 6 centimeters long and 4 centimeters high. So again, with these kind of with these questions, they can really help, because sometimes when we're actually working with calculating volumes and especially surface areas, it can get a little bit confusing. Like when we look at this, if we want to know the surface area, it can be quite difficult to actually picture all of the different components of that shape. If we imagine the different views of it and maybe even do sketches of them, then this kind of helps us to kind of go, oh, okay, well, if I'm looking down on it, it is just a rectangle. So that means it's got a rectangular base. The front elevation, well, that's the slope part of it as well. So if I was trying to work out the surface area of this, it would essentially be 2 triangles, 1 on each end, and then 3 rectangles. So the last one here then is we need to look from the left side elevation. So if we're looking from this side here straight at it, then what we're going to see is a triangle. And that's where that 5 centimeter dimension comes in. So if we're kind of looking at and talking about nets as well, they do tend to kind of ask these questions again, more of a level 1 question, but it can pop up on either. A net is essentially just a 2-dimensional drawing of something that can fold in a certain way to make a 3-dimensional shape. There can be more than 1 net for each shape. And in functional skills, we may be asked to like draw a net of a shape to scale, or to identify what the net is of a shape. So the net that we've got here is one of the many nets for a cube. So if you imagine, if we folded the sides in and then we kind of rolled it over, it would make a perfect cube. We'd have all the faces on there and obviously a hollow inside. So you have a little bit of a look here. I'll let you guys potentially answer this one, so pop an answer across. But if we're looking here, so which one of these, or which of these, there might be more than one, which ones of these can actually fold to make a cube? So just pop the message over to me and we'll have a look and see how we're doing with this. Like that. So we've got an idea coming in there. That's good. So the thing with these is it can be a little bit difficult to see sometimes because it's, you know, obviously we can't have anything like overlapping. It has to be a perfect net, which is what it's asking for. So the actual answers here, it's only shape D that will actually fold properly to make our net. If we look at shape A, for instance, if we imagine, you know, if I fold up these two sides here, I've got a side and a top. I can then fold like the one square round, but I'm going to end up overlapping on the top and I haven't got anything for one of the sides. Shape B as well, similarly, when I fold that shape together, it's not quite going to make it. So no one's put down shape B, so that's absolutely brilliant. Shape C as well, when you fold that, it ends up overlapping itself. So again, I think with that, it's the idea, it's just showing it's got to fit perfectly. So we can't have any overlapping or anything like that. So D is the only one there that is a potential or one of the nets for a cube. So let's have a bit of a look at some kind of exam style questions on this then. So this one here, obviously, I know you guys can't really draw along, but just to kind of, I'll talk you through this one and kind of show you what it looks like. So this is from a level 1 paper, but again, there's been very, very similar ones of this on level 2 papers as well. So we get given an area here, and it just says there, so draw a net of the open box and use the grid to draw your net. We've got our key down there, so that's going to give us a scale factor as well, so that's brilliant. So the scale factor there, then it's 1 square represents 5 centimeters. So if you're following that scale, we're going to get some potential marks there. We can see it's a 3-mark question, so we can kind of roughly gauge where we're going to get these marks. So sticking to the scale is going to get us a mark. This is quite a nice one because it's, you know, even if there's a little bit of an error at the end, you'll probably still get 2 of the marks there. They do tend to be quite generous with these questions. So Jacob is a florist. He designs an open box for flowers to stand in. So that tells us there is no top to this shape. So what most of us would look at then is that, well, if I fold down all of those shapes, and again, it does say just draw a net. So there are multiple different versions of how you could draw this. I think the most common though is just thinking, well, if I've got a base, if I just fold the sides out, then it's going to end up looking something like this. So I can fold all those sides in. I haven't got a top. That's absolutely fine because it's an open top. And it's just sticking to the scale. So we know that in reality, it's 20 centimeters. Each square here is 5 centimeters. So that's going to be 5, 10, 15, 20. So it's all based on working with 4 squares there. So that's one kind of example question there. This is an example of a level 2 question. So very similar. But again, this is part of a 2-part question. I think it actually kind of asked some extra information after. But so we've got Maisie is designing packaging for a perfume bottle. The packaging is in the shape of a triangular prism with a length of 160 millimeters. So Maisie has drawn the front elevation and the plan of the prism on the centimeter grid below. Maisie needs to draw the side elevation to complete the design and drawing. So they've worded it a bit differently. I haven't quite given you all the information, but we can pinpoint things from this. Well, we can see here, well, this is 160 millimeters, which tells me that this length here, if I'm looking from the top, it's this length here, is 160 millimeters. So if I count those squares there, I can see there are 8 squares along. So 8 squares is equal to 160 millimeters. Therefore, each square on our grid there is representing 20 millimeters or 2 centimeters essentially. So I can pop that in down here. Obviously, one of the marks here, it asks you to complete this and add the scale. So that's going to get us 1 mark, perhaps even 2. I can't remember exactly how many marks it was for this question. We then need to draw the side elevation. So given the like the quick sketch that we've got there, if we were looking from the side, so we can see if we're looking from the front, we've got just this kind of nice, like nice looking triangle. From the top, we've got 2 rectangles. If we're looking at it from the side, we're just going to see 1 rectangle essentially. And we can now use our kind of our scale that we have to work out what this is going to be. So it's going to be 8 centimeters long, and it's going to be 4 centimeters wide. The reason I know it's going to be 4 centimeters wide, so I'm looking at it from this side, so from over here, I know it's a rectangle and it's the same length as the plan, but the actual height of it will be the same as the height here. So the height here is going to be what I see when I look at this from the side. So just one more kind of style question here, and this is the example that I was kind of saying about a little while ago. So the front elevation and the side elevation of a cuboid have been drawn on the grid below. So draw a plan view of the cuboid on the grid. So again, this just kind of, you just need to kind of think a little bit about this and to kind of see, well, what am I seeing here? So, you know, if it helps you draw a quick sketch of it, maybe put some of the dimensions on there, that can be very, very useful. What you're also asked is, obviously you can see there, so it says part B is to draw a plan of the cube, but for part A, they actually ask you, what is the volume of the cuboid? So it's quite an interesting one, but again, if you do a little bit of a sketch, then you can work out all of the dimensions here. The answer is going to be 72 centimeters cubed. How I've worked that out is that if I'm looking at the side, so I'm going to draw my cuboid first of all, I'll do a little sketch up here. So this is what my cuboid is going to look like. We know that, that's absolutely fine. If I look from the side, I can see that it's 4 long. From looking at the side, I can also tell the vertical height as well. So the vertical height is going to be 3. If I'm looking at the front then, and obviously this isn't to scale because this side's longer, but if I'm looking from the front, I can see, well, the height's the same, it's still 3, but it's going to be 6 long there. I can then use that information to work out what the volume is. Quite a strange question. And again, it did throw quite a few people, but just from looking at this, we can work out all of these things. So we can work out the volume. We've done that. That's our part A. I think that was worth 2 marks. For part B, then it just says to draw a plan of the cuboid on the grid below. As long as you draw a rectangle, it doesn't matter the scales or anything like that, you're probably going to get 1 mark there. For using the correct kind of scales, you're going to get the extra mark. So if we're looking at the plan, we're going to be looking from the top down. We're not going to be able to see this this height at all, but we will be able to see the depth here and the width here. So when we actually draw this, I know it's going to be, if I'm looking from the top down, I know it's going to be 6 centimeters along the front and 4 centimeters deep, essentially. Okay, so that is our plans, nets, and angles there. Again, it's one of those difficult ones. It's always good to have some practice questions, but for these, it's very difficult for you to actually sketch them out and stuff. So it's probably better for us just to talk through these. What we need to have a look at now then is our angles. So with angles, so in regards to functional skills, what we need to be able to do with angles is we need to be able to measure an angle. So we need to be able to use a protractor, obviously put that on and be comfortable measuring the angle. I'm sure most people are very comfortable with that. It's not too much of an issue. We need to be able to name different types of angles as well. This is mainly for level 1. I haven't really seen it asked at level 2 as like a direct question, but they do tend to kind of make the assumption that you know the names of these. So they might say This angle is an obtuse angle. That gives us quite a lot of information, but we need to know what that means. But for level 1, it might just say, tick the angle which is obtuse, or tick the angle that is a right angle. What we also need to know, we need to know a couple of just basic facts in regards to these. So we need to know how many degrees there are in a quadrilateral, how many degrees there are in a triangle. We need to know how many degrees are in a straight line, and we need to know how many degrees are in a circle. Essentially, if we know all of that, we're absolutely fine. There is a little bit of information in regards to kind of parallel line theory. But like I was saying before, so the level 1 questions are typically kind of measuring an angle or naming the type of an angle, whereas level 2 questions, they tend to be kind of combining the knowledge of angles to find a missing angle. It can look like algebra, but it's not really. It's more, use these facts to work something out. It's like it's more like geometry. But for me, this is like my favorite subject, but I don't agree with it being in functional skills. It doesn't seem to have much relevance in there. It's not very real life based. And also it doesn't ever really seem to link in with a functional problem. They just tend to give you a drawing and say, what is this? Which is very uncharacteristic of the general way that they do questions. So an angle in itself, then this is just a turn essentially. So if you imagine looking straight ahead, spinning all the way around in a circle, then that is a full circle. That is 360 degrees. If we're looking forward and we turn, 3/4 of the way, then we've got a 3/4 turn. And again, we just do the same with the degrees there. Obviously, it's going to be 270. It's 3/4 of a turn. We've taken this, divided it by 4, times it by 3. Half a turn then is going to be 180 degrees, and a quarter of a turn is going to be 90. So for us, the real important ones there are like half a turn and a quarter of a turn. The quarter of the turn is actually a right angle, so that is 90 degrees. And that is always, that is just a fact, all right angles are 90 degrees. So we can use that to build on other ideas. The half a turn as well, I'm hoping you can see that there, it's essentially a straight line. So that tells us the amount of degrees in a straight line. So that's very, very useful as well. So when you get some of these, like these types of questions, and it might look something like this. So this is an idea of kind of our angle, like our straight line theory, but they have been asking more questions like this. So if I give you guys a minute just to pop an answer over. So how many degrees do we think are in angle X at this point? Given we know that a straight line is 180 degrees, so how many degrees must angle X be? Oh, okay, absolutely brilliant. Yeah, so Claire, no problems there. Jackie, that's absolutely spot on as well. So with this, and all we're doing, we're looking at the angles and we're just saying, well, if it was a straight line, it'd be 180 degrees. This part I know is 55 degrees. So the remainder has to be the rest of that. So in this case, we've got angle X and this 55 degrees equals 180 degrees. So if I take away 55 degrees, then I'm left with 125 degrees. So again, you can see where it's starting to look like algebra. All algebra is really is just, instead of putting like a question mark, we put a letter in instead. It's just finding a variable. So it's not actually anything to worry about. So another kind of just bit of an idea here then. So the angles around a point are 360 degrees. So we know any point, if we go all the way around it, we're doing a full circle, that is 360 degrees. So given that then, how many degrees have we got here in angle Y? So I would say as well, please do use a calculator at this point as well. I know for most people, you've been at work all day, you've been doing this. As long as you've got a method for addition, subtraction, multiplication, division, that's absolutely fine. It's more a case of, you know, we can practice those skills, but if we're working on specific topic-based questions, it's better that we kind of use more of our kind of our brain power to think about how we will solve a problem than actually working out the actual sum itself. Yeah, absolutely brilliant, guys. Yeah, no problems there. So this one's going to be, the answer will be 117. The reason being, we know that all of these angles together add up to 360. So again, if we, you know, the way of solving it here is obviously I've done 151, added it to 92 to get 243, and then taken that away from 360. Just one way of viewing it there. So yeah, so we've got 117 degrees there in total. So these ones are quite nice and straightforward, but again, they tend to, as we'll see when we look at some examples, they tend to kind of build these questions based on these bits of knowledge. So you might have a point around a circle that links to something else, for instance. This is something that's like popped up, and again, you don't need to remember the actual the technical names for them. So opposite angles, they always tend to change the names these days anyway. But with this, it's just the idea that angles that are opposite are the same, essentially. So what we know here is if I imagine this line, I know, so angle Z here is going to be 63 degrees. It's going to be the exact same. The reason being, if I've got two straight lines that cross over like this, obviously they're both going to be the same. If I increase or decrease the angle, so if I move both of these straight lines down, obviously the angles on the inside, which is 63 at the minute, is going to get smaller, so maybe 60, 55, and so on. It will get smaller and smaller, and the angle on top will get bigger. So everything's in proportion to how these move. So if you just imagine we've got our two lines there, most people can just see straight away that it looks the exact same. And if that's your gut instinct, I'd say go with it. The reason they are the same, though, is because if they're crossing like this, if I move even one line in one direction, it will impact both sides of this equally. Again, like I said, this, if you were to imagine moving these lines kind of closer together, so we kind of move them inwards, angle Z and its mirror angle, the 63 degrees, are going to get smaller, whereas the top angles, so like now, if I'm looking for angle Y, for instance, angle Y is going to get bigger. I can work out what angle Y is as well if I were to look into this, because I know all in all the way around that is 360 degrees. I've got 63 and 63, so I can take them away, and then whatever I'm left with, I just have to half it because it will be mirrored from the top and the bottom there. Okay, so the angle theory behind any quadrilateral, and this is the same. So, you know, it's very easy to see how this works with squares in particular, but this will work with rectangles or even stranger looking shapes. You know, you can get weird kind of looking quadrilaterals, which they will still always add up to 360 degrees. The reason being, if we think about a square, it has, or it is comprised of 4 angles, and they are right angles. Each right angle is 90 degrees. So in total, it's going to be 360 degrees. So here's a nice kind of image of that. It's always going to be 360 degrees. It will be the same in different quadrilaterals as well. So even like this one here that doesn't quite look the same, it will still always add up to 360 degrees. The reason being, it's just about the idea, and there is a bit of a demonstration in a second that will show you how this works with triangles in particular. But if I imagine, like, if I were to take one of the angles or one point or vertice of this square and say move it inwards, by moving that angle inwards, it will impact the other angles, but it will always stay in proportion. So if I were to pull it out, it's going to stretch those angles a little bit bigger and reduce the angle of its own. It will make a bit more sense when I show you the demonstration with the triangle. But the main thing for us to know is any quadrilateral is 360 degrees. We need to be able to remember this. Triangles are absolutely fine as well, and it's the same premise of when we look at how we calculate their area. We know that if we have a triangle, or to find the area of a triangle, we find the area of the rectangle, and then we chop it in half. A triangle is always half of a rectangle, and it doesn't matter what type of triangle it is either. So knowing that, it's the exact same when it comes to the degrees. If a A quadrilateral has 360 degrees. A triangle, regardless of what type, will always have 180 degrees. So if I imagine I've got my rectangle there at the top, I've then chopped it in half and I've got my triangle. So it's literally the exact same idea as when we calculate the area. We have the rectangle, we chop it in half, and then we end up with our triangle. So that's how we find the area. It's the exact same when we're looking at area. And this is a prime example because it works very well with a right angled triangle. You can clearly visually see the link there. Even if it's a different type of triangle, though, you will still have 180 degrees. There's a couple of things to note about different types of triangles as well. And they wouldn't expect you to know these. So if it is what's called an equilateral triangle, that means that all of the angles are equal. It means all of the lengths are equal as well. But an equilateral triangle, all of the side lengths are the same, and therefore all of the angles are the same. It's 180 degrees in total. I've got 3 angles, therefore every one has to be 60 degrees. The next type of triangle I've got then is an isosceles triangle. And you might see like these kind of lines sometimes drawn on an image. They mean that those lines are the same. So in this case, with an isosceles triangle, I've got 2 lines that are the same. Because I've got 2 lines that are the same, it means that the 2 angles will also be the same. So with an isosceles triangle, these 2 angles will always be the same. This one here will be different, but we can use this to work out quite a few things. If I'm given one angle, I can work out all the rest. If I know my triangle is isosceles, if I'm given, say, this angle here, and let's say they say it's, I know, 40 degrees, I know that the other angle across from it has to also be 40. So both of those angles will be 80 in total. It means the top angle has to be 100 degrees. The last type of triangle that we have is called a scalene triangle. And there's no real rule for this at all. It will still have 180 degrees in it, but all of the angles are different because all of the lengths are different. So they might kind of say, you know, if they give you a drawing or an image, because they're not always drawn to scale, obviously. So they might say this part here is an equilateral triangle. That gives you a lot of information. If they say it's an isosceles triangle, they put these marked lines on there, then we can use that to our advantage as well. So this was the idea that I was kind of getting at about the like how if you move one specific angle, how it impacts the other angles. This will be the exact same with a square as well. But this is just to show how, you know, if you grab one part of this and you move it, so there it's like moving point A. As point A moves, it has the like the impact on point B and point C is kind of split between them. So one angle will get bigger, which means the other will get smaller. So just a bit of like a visual demonstration there. So, you know, and this is the exact same if it was a quadrilateral. But it's just to show that all of these angles are going to be the same. So it'll always be 180 degrees there. So we do need to know a little bit about parallel lines. There is a little bit of kind of fancy wording at this point, but you don't need to know any of the specific terms. It's just more being aware of certain extra bits, really. I haven't really seen them ask any questions involving parallel lines, but I don't think that means they can't. So parallel lines, all parallel means is it's 2 lines that they have the same, what's called gradient, so the same steepness. So I always imagine like train tracks. You've got 2 lines and they're both perfectly at the same angle. They're just going along there. A transversal line then is a line that crosses between these 2 lines. Essentially, the main thing that this tells us is that where that line crosses, it's essentially making 2 copies of itself. So at this point here, where this crosses here, because it's a straight line and because these 2 lines have the same gradient, this part and this part will be the exact same. So if I look at my image, and this is all like kind of the line theory kind of works on, well, okay, this angle here, for instance, if I look at this angle here, like the bottom right angle, we can call it, we'll call it R. But if I look at angle R, that's going to be the exact same as here. And it's just spotting that little trend, really. Again, it'll be the same for the top part. So this top angle here will be the same as this part here. So it's quite an interesting link. If I was given this initial angle here, R, so for this part here, if I was given this, I could work out this angle here, because I know that the angle on the bottom is going to be the exact same, and then the part on the top is going to have to add up to a straight line. So it's these kind of little logical steps that they tend to build on a little bit. Again, we don't need to know the names of these, and they do constantly change them. But with things like this, so we have alternative angles are equal. So this is one thing. And again, if you imagine, all you have to do here is just imagine, so I've got this straight line coming through, and that means that all of these angles are replicated on the bottom here. So why are these angles the same? If you imagine, if I chopped this angle out, if I used, my cutting tool, I cut it and I just turn it around and put it on the top, it would fit perfectly here. It's the exact same angle. And you can just kind of imagine, hopefully, how that works. So if I just kind of chopped out this, spun it around, it will fit perfectly into that space. So that's why these kind of alternate angles are the same. What are called corresponding angles, or F angles. Again, it just looks like an F. We've already looked at this, but these are the same as well. The reason being, it's a straight line going across it. Everything here, essentially, if I cut that, I can just paste it perfectly here, and it looks the exact same. So it's because this here is like the bottom right angle that we just looked at, and this is going to be the same. The last one they have then is, what they've called here C angles, or interior angles. And these both add up to 180 degrees. The reason being, again, this is the bottom part of the angle. This will be replicated here. Yeah, if I were to cut this out and move it down here, it's the exact same. So this angle here, let's call it A, is going to be the same as this part here. It's the exact same because it's a straight line cutting across two other straight lines. As I can see, this is a straight line, so A, and if we call this B, together, they will be 180 degrees. Looks a little bit complicated. Again, the wording doesn't really help, like alternative angles, corresponding, interior, but we don't have to learn any of those names at all. It's more just, training your eye to kind of spot these things a little bit and just come in, oh, that is the same as there because it's a straight line, and just being aware of why this is. So if I want to look at, say, this example here, then, so if that angle in the top left is 70 degrees, then angle C itself will also be 70 degrees. If you imagine, if I kind of cut that, spin it around, it's going to be the exact same. If I'm looking here, then, so this is essentially an interior angle, or a or like a C angle. So with this one, I can see, well, that's 75. Again, if I were to move it, it will just sit perfectly up here. It's the top angle part of here. I know that together, these will equal a straight line. So I've got something, angle D, and 75 are 180. So I can just take 75 from 180, and I've got 105 degrees left. Corresponding angles here then. So again, I'm hoping you can just spot there straight away. You don't even really have to do any maths. You just like, oh, it's the exact same. 72 degrees, it will be 72 degrees. So it's like a back to front F, essentially. Okay, so here is an exam question that has popped up recently then. And again, it was a two-part question, and they've asked you to use an estimate to check. So what I want you to do is have a go at this one. Have you done this one before? Someone say. Oh. Hello?
No, I haven't done it.
Oh, okay. So, sorry, I thought you just went, I've done this before. I was like, oh, sorry, Mark. Okay, brilliant. So everyone have a look at this one, see if you can work it out then. And again, just remember, there might be one or two steps. And again, use our marks being awarded as guidelines. So I know if it's 2 marks, there's probably 2 steps to do. But I'm hoping you can see as well where this isn't very functional at all. It really does break down a little bit, and it can really throw learners, is what I'm noticing. If you're looking and you're expecting to see these worded problems that you've been practicing for, and then you see this, it looks completely different, and it can really throw people because it looks just a bit strange. So just remember those key facts that we have. Straight lines add up to 180 degrees. All the angles in a triangle will be 180 degrees. So using that, we should be able to work out what angle X there is. So I'll just give you guys a minute for that
I've
one.
got it now.
Claire, I believe the answer you've got there is spot on. So I'll go through this in just a second. Yeah, so yeah, the answer you've got is absolutely spot on, Claire. But again, it's nice when I find these questions quite nice and relaxing, really, because I look at it and I go, oh, cool, I've got to work out X. And you just have to pick the other bits. It's basically working out each step that you can fill in. So you haven't got all the, it's always like a Sudoku kind of puzzle, really. You look at it and it's like, oh, I can't get to that answer yet, but what I can do is work out this part. When I work out that, I can then work out this. And then when I work out that, I can work out this in the end.
What the answers that I've submitted, would that be classed as an estimation? I don't really know how to quite to get to an estimation, or would I do 180 minus 60, or I don't know how to get the estimation part.
It is a bit of a strange one. And again, I think that does for people. The thing with an estimate, if you're ever asked to use an estimate, first of all, always make sure you change at least one number. So there's no right or wrong way of doing an estimate. The only way you're going to lose the mark is if you actually do the sum normally.
Right, okay.
So that's quite a common one. I've seen people who have done amazing pieces of maths and like they've done these really complex sums, but the actual question asks you to use an estimate.
So I could do 180 minus 60 just for talk's sake.
Yeah, right. Absolutely fine. Yeah, and that's what I think most people would round this to. You'd kind of go, well, 58 degrees, that's pretty much 60. 63 is pretty much 60 as well. It just looks a bit strange when you actually write out this sum with estimates. It's everything is just 180 and 60, and it's taken this away, adding it, and it looks a little bit strange. But the thing with estimates, so long as you change at least one number, so some people, they might round 58. I don't know. You might just round it to 59 for some reason, but you'll still get the marks for it. So long as you change it by a little bit, you'll be fine.
Yeah, okay.
So if I can go through this question then. So what we're looking at first of all then, we need to find the missing angle inside the triangle. So I've got 180 degrees in my triangle. So my triangle ABC, I need to work out what that missing angle is. So if I take away 58 and 63, I'm left with that angle. So that tells me that that angle there is 59 degrees. So now I know this, I can work out what X is because it's already told me ACD is a straight line. So a straight line adds up to 180 degrees. So therefore, I'm going to do 180 degrees, take away my 59 from the triangle, and I'm left with 121 degrees, which is for angle X. Like we were just saying, if you're going to use an estimate to check this, again, just change one of the values there and just repeat the sum. So in this case, I'm going to say, well, 63, that's pretty much 60. Angle at the top, 58, that's pretty much 60 as well. So I'm going to round those both to 60. 180 minus 60 will tell us that this angle here is approximately 60 degrees. And then to work out the straight line, I can do 180 degrees, take away 60, which leaves me with 120. But again, it's not too bad. And if you actually look at that now, I mean, that's 3 marks. That's a very nice question to actually pop up. We only have to do 3 simple sums. but it's more, these can just look quite intimidating for people. They are getting a bit more wordy with them as well. But so long as we can just remember triangles 180 degrees, straight lines 180 degrees, any quadrilateral 360. If we can remember that, we should be absolutely fine. So here is another example then. So this one popped up a little while ago. And again, I'm assuming that you're with me on it. It's very not functional at all. But if we have a look at it then, hopefully you can see or like calculate the value for x. You'll probably think of a number immediately. That's probably right. To be honest, if you just look at it and you go, oh, it's this many degrees, that's probably absolutely right. It's just how it looks. But this all links in with the idea. So it says PQRS is a quadrilateral. So it is a four-sided shape. It just looks a bit strange. But given that, we know what all three-sided shapes, all four-sided shapes total up to. So we should be able to work this one out. So have a go then. If you work out what x is, then just again pop over the answer, let me know, and we can go through it in just a second. Mark, yeah, absolutely brilliant, and Claire as well, absolutely spot on there. So, like, and with that, this is one of those things where if you know it, you get the mark. If you don't, then there's no way you can calculate it or work it out. But angle x itself is going to be 84 degrees, like you said. The reason being, it is an opposite angle of the 84 degrees on top. If you imagine those lines like this, if I were to move them both kind of inwards, then that angle, they will both get bigger in proportion, and the ones at the side will get smaller. So this 84 degrees is the exact same as this. So now that you know that, you should be able to go a step further and work out what the total degrees of angle Y are as well. Okay, so a couple of different answers. I haven't seen the correct one yet. With this one in particular, just remember that PQRS is a quadrilateral. So that means that all of the angles will add up to 360 in total.
Yeah.
So if I go for this, so the angle that we're looking for here, then we should. So to actually work this one out, we need to input our 84 degrees, but because it is a quadrilateral, although given it's a very strange one, it's looking at this shape here. So we've got our 1, 2, 3, so 4 lines there. So we've got 360 degrees. We're going to take away our 84 degrees, which is angle X. We're going to take away our 27 degrees.
33.
Absolutely spot on. Yeah, Mark, that's brilliant. Yeah. So when we actually take all of them away, we're going to end up with 33 degrees there. And this next be click. There you go. So again, it does look a bit intimidating, and some of these questions can, but they are all based on the very simple premises of things. It's just, triangles 180 degrees, right angles are 90 degrees, quadrilaterals 360 degrees, straight lines 180 degrees. If we can just remember those kind of facts, then you'll be absolutely fine. And the memory aid that I've kind of sent out and that I've mentioned is on the Classroom. I would definitely recommend having a look on there. So if you haven't been on the Classroom for a while, if you go on there and go down to I think it's topic 13, it's called like the Classroom review. If you go on there, there is just a little memory aid. All it is, it's just a PowerPoint that is one slide, and it just has all of the bits that you need to put to memory on there. So it's just remembering your metric measurements, calculating areas and volumes, your statistics. It's got all of the stuff there, so you can essentially just print it off or just, you know, cover it up on the screen and just see if you can remember it all. Okay, so what I've now got then is we've just got a load of random questions, essentially. This in itself is a question that tends to pop up quite a bit, and it does throw people a little bit. And this is, so it's a completely different topic. So we're done with our angles now. We've looked through them. We've learned everything that we need to learn. We've looked at some examples. So the rest of this PowerPoint is just practice questions and the answers on there. This question itself takes a little while to calculate and can take a little while to work out, but I think it is worth potentially having a bit of a think about it and trying to kind of remember how to do these types of questions. I'll give you guys a minute or so. Just have a look. If you are completely lost, and do just pop me a message over, or again, there's not too many of us, so just shout out to me. I have no idea. It's absolutely fine. We can go through them, but we are just going to be looking at random different topics now and just seeing what we can remember, and then obviously talking through them as well. So this is from an NCFE exam, which we don't use that exam board anymore. We use Edexcel. Personal preference, but I think they're considerably better. The wording's nicer. But this is a good example of these types of questions. So this is the idea of finding an average of a mean. So I'll give you a couple of minutes and then I'll start going through a solution for it. Again, you don't necessarily have to calculate all of the values here, but as long as you've got like an idea as to how you would start to work this out, that can be very, very useful. So how we find this one? Is anyone kind of completely lost with it? Doesn't have any idea where to start, or?
Yeah.
What was that? Sorry. Oh, hello, Mark.
Yeah.
Any idea where to start with this one, or is it a bit?
I added up the number of jobs divided by 4.
It's a good idea. It's got potential, you know, at least we've done something with it. That's always a good way.
It was 31.75, maybe not minutes, maybe hours. And then the 75, it has to be a 60. So then I made it 32.15. I didn't know whether that was minutes or hours.
Okay. Well, again, it's a good kind of starting process with it. So this is an example of what would be probably the worst or the hardest question that you're going to get asked on finding a mean. So we have our, you know, calculating the mean, the mode, the median, the range. These are finding our different statistics. So here it says what is the average time it would take him. It is worded quite badly there, because if they use the word average, then you can technically find a median or a mean of it, but they tend to say in the newer papers, they'll always say the mean average to kind of avoid any confusion there. So if we remember, when we're finding the mean, this is the one where we add, to find the mean, we've got to get mad. So the mean is addition and division. So whenever we're finding the mean, if we just have a set of numbers, we just add them together and divide by how many there are. So kind of like what Claire started to do there, okay, well, I can add these together and then divide by 4. If it was just those 4 numbers, then that would be absolutely perfect. You found the mean. The issue that we have is this is the number of jobs that he's done. So this is a frequency, and this is how long they've taken. So the reason this is the worst type of question is normally they might give you an exact amount. So it might be, 60 minutes, 90 minutes, and so on. With this, we have to use an estimate because out of those 25 jobs, they've all taken between 30 minutes and 60 minutes. That's what these extra lines mean here. So it means it's greater than 30 minutes, but equal to or less than 60 minutes. So that's all this bit here means, although it looks very technical with the little inequality signs. So all we do, the first thing that's going to get your mark here is when you're drawing this out, making that estimate. What I'm going to do, I can't say exactly, and again, I haven't got the data here to tell me exactly how long these took. All 25 of the jobs might have been completed in exactly 30 minutes. They all might have been 50 minutes. Some of them might have been 30, some might have been 31. We have no idea, but what we can do, we don't need the exact information. We just need an estimate. So what I'm going to do is I'm going to say, well, all of those jobs then, if I look between these two, I'm going to say they're all about 45 minutes. To find that, it's almost like meanception. You have to kind of actually find the mean of these two numbers. So we're looking for the middle. For most of the time, it's very simple. You can just look down and go, well, between half an hour and an hour, it's 3/4 of an hour. It's 45 minutes. But one of the marks is going to be for putting that information in there. So I know this is going to be 45 minutes. What I'm then saying is, okay, well, it's taken 45 minutes for that first job, or in this section here, and there were 25 jobs that took that amount of time. So first of all, sorry, I'm just going to go through, kind of find out all of the different averages then. So this part here is just showing you how I've got to that answer. So what you can do for this one here, if you can't spot immediately, between 60 and 90 minutes, what the middle ground is, what you can do, add them together, as we've kind of shown here with the first one, add them together. So that'll be 150, divide it by 2, and that will then tell you what the middle value is. So here it's going to be 45 minutes, here it's going to be 75, then we've got 105 and 135. So we're going to use these estimates when we work out the number of jobs. And like we were saying before, if this was data and it was just written out in a nice long line, we'd have the 25 jobs and it'd just be 25 different numbers. Then there'd be another 36 different numbers and they'd all have different times attached to them. In total, there are, how many is it? 127 jobs. So there are 127 different bits of data. If we looked at it like that, it's going to be harder to see it. And obviously it's not the nicest way of looking at it, but for us calculating the mean, it might be easier. We can just add all of them together, all 127, and then divide by how many numbers there are, which is 127. So we add all the values, divide by 127. What we're doing here is almost just like a bit of a shortcut. We're using these estimates, and then we're just going to do a little bit of a shortcut. So I know that 25 of the jobs took around 45 minutes. So I'm going to multiply that across, and I've got a total of 1,125 minutes. I'm going to do the same for the next one. So there were 36 jobs that took 75 minutes, 45 jobs that took 105 minutes, and 21 jobs that took 135 minutes. I'm then going to add all these together, and I've got a total. So in total, the amount of time that he spent on these cleaning jobs is an estimate. He spent 11,385 minutes cleaning stuff. He's a very clean person, old Paul, apparently. So he spent all this time cleaning stuff. In total, there were 127 jobs. So if we're looking for the mean, we're going to take that value, divide it by 127, and it tells us that on average, I've rounded it to 2 decimal places there, and they might ask you to do that as well. They might embed that extra little skill there, nothing to worry about. But on average, then it's taking about 89.65 minutes per job. We can always kind of check this answer just with a bit of an estimate, because I know all of these values here are quite similar, 25, 36, 45. So my mean should fall somewhere in this area, really. It'll be around the middle. If it comes in at 80, 89 there, then that's a good estimation of the mean. It's coming in at the higher end of this spectrum here. How does that work as an explanation? Is that okay for people? Does this question make a little bit more sense now? Cool. Okay. Yeah. I've got like a nod and a smile from Mark, and Claire's just like, yep. So it is one of those questions that, again, it does tend to throw people. Normally, if we've got a question on averages and statistics, and there will be one, it's normally a nice straightforward one. They just say, what is the mean of these numbers? Or what is the median of these numbers? Nice and straightforward. Sometimes, though, you might have to take the information from a table, and it's just remembering what the information is on that table. We're still doing the same thing when we're working these out. Okay, so let's have a look at a random question then. So this is just an exam style question. I'll have to talk through this one, but this is in regards to our kind of data question. So again, this is more of a level 2 style question. The level 1 questions, they tend to kind of use more quantitative data. So it's more kind of drawing what they called, like line, not line graphs, but kind of bar charts, essentially. So the idea here is I've got this information. So the scatter graph shows the information for 12 athletes who have just run a race. And what we can see there, we've got the time up the side there and the age along the bottom. So the main types of questions that are popping up at the moment, you might have to draw or add data to a pre-existing table or chart, and they quite like that. The other one is it's spotting trends and patterns as well. That's a really, really common one. So part 1 of our question then, it just says here is the information for another athlete. He's 36 and the time taken to complete is 29 minutes. Plot this information on the scatter chart. So again, 1 mark is a very nice mark to get as well. We're just going to look across to 29 or to 36 even, so we can work out his age here. Just be careful with the actual points there. So they can ask you to measure between, either be between the square or on the square, essentially. But if we look into the age, okay, well, this is 30, this is 40. There are 5 squares, so each square is essentially 2 years. All I'm going to do, I'm just going to draw a line straight up from my age there, and then I will mark it across here to where it's 29. So that is where my point is going to go on that kind of vertex or on that corner there. So the next question then is draw the line of best fit for the scatter diagram. So is anyone...
Tom, can I ask a question there?
Yeah, of course.
Does it matter if you just put your cross in, or do they expect you to draw the lines?
Really, really good question. You can just put the cross in.
Okay.
I've just kind of put those construction lines in just to kind of show exactly how you would work out where it is.
Okay, thanks.
No, you're absolutely fine though. You can just look across and just kind of scan it and go, right, it's there. So
okay.
And this tends to be the pattern where they tend to kind of, they'll give you some data and they'll ask maybe 2 or 3 questions in a row, and they're all just 1 mark questions. So the next one that we get then is this idea of, can we then draw a line of best fit on the scatter diagram? That's a very nice question because they've told us exactly what they want us to do. If you remember our line of best fit, we're just going to draw a line on there, and it might look like this. It might look a little bit different. It is a way of getting an estimate of the data. So we can see here, we've got the time in minutes, and then we've got the age, and I'm just drawing a line. I want to try and get as many points as possible on either side of that line. And again, they do give you a range of answers for this. They don't always tell you to draw a line of best fit. There was a question that had popped up recently where they gave you this data and it said, make an estimate of a person who is, let's say, 40 years old, and how long you think it should take them. If they ever say to do an estimate, to get the estimate, we need a line of best fit. So they can just expect you to draw that without being specifically told to. So with this, and we've got all of this data, the line of best fit just goes through the majority of it, and we can then use this to make kind of predictions as to what we would expect to find. So for question C then, we've just got our very nice, and again, very nice, straightforward here. So describe the relationship seen there. So I'll let people pop in an answer for this one. So can anyone tell me what the relationship is on that scatter diagram?
It's a positive, whatever they call it.
It's a
Got the
positive
word.
thing. So it's something and it's positive, and that's all I'm telling you. Yeah. Absolutely spot on. Yeah. So it's what's called a positive correlation.
That's the word.
Yeah, it's a really, really good point. That what you've just said is really good, because again, sometimes we forget these certain words because we don't use them all the time. The nice thing is, and it does come down to the wording. So they've said here, describe the relationship. They can word it differently. They might say state the trend, or they might say what is the correlation sometimes. So knowing that it's positive is a good thing, and even just writing positive will probably get you the mark. There is a way around it as well, though, because it says to describe the relationship. Even if it says, what is the trend or what is the pattern, you can just describe what is happening. They're just testing that you can read it off there. The optimal language is, it is a positive correlation. The reason it's a positive correlation, it is in proportion. As one increases, so does the other. If it was a negative correlation, you'd have a line going the other way, and it would be obviously as one thing increases, the other decreases, essentially. But you can just describe what is happening and you will get the mark for it. So in this case, if you were to say, as age increases, so does the time to run in minutes, or the time is longer for older people. For either of them, you will get the mark for it. So if you can't remember the actual specific word correlation, you can still obviously get those marks there. But just to show that, so they do, so we can already see that that's 3 questions straight away on this. So that's 3 marks, just each one. Can you do this? Can you do this? Can you do this? So it's positive correlation. And again, like I said there, as age increases, so does the time taken. You can write either of them in there. They haven't asked any further questions, but what another type of question that they might ask is something like, they might say, use your line of best fit to make an estimate, or they might just say, estimate the time it will take someone who is 20 years old to complete the race. And all you're going to do is kind of what I've drawn here with the construction lines. I'm just going to go from 20, measure up to my line of best fit, and then measure it off and say, well, it'll take them an estimate about 14 minutes. And that's what we're expected to be able to do. Okay, so here is a random level 2 question for you then. So have a look at this, have a bit of a read and see how you do with it. So I believe this is a question on probability, could be on level 1 or level 2 really, but this was from a level 2 paper. Claire, it's a good idea. You've got a bit of it there. It's actually even simpler than that. But you're right about writing this as a fraction. You could, if you wanted to, write as because it's a probability, you could write it as a fraction, as a percentage, or as a decimal. It's absolutely fine. But you're just thinking, if there's 150 things there and you're taking one at random, what is the probability? Or what is the chance of that? And if you just say it out loud, well, there are 67 blue balloons in there. So the chance of actually getting one of them is 67 out of 150. There's 150 potential options. 67 of them are blue. So it's actually a very, very nice kind of straightforward question there. Now, does that make sense, what I was just saying about? Yeah, cool. It is just one of those things where, again, sometimes you look at this and you can kind of think immediately, well, hang on, what's the trick? It can't be that simple. It is actually quite nice and straightforward with this one. And again, use the marks to kind of help out. This is a 1 mark question. So essentially you've got about 1.8 minutes to answer this. So It's not a whole lot of time, but they are essentially the 1 mark questions. It's almost just, doing completing one sum or just stating a fact essentially. So in this case, then we've got 150 balloons, 67 are blue. So it is 67 out of 150 are blue, just writing it as a fraction. Okay, let's have another look at a random question then, see what we get. Okay, here we go. So again, another kind of statistic question then. So what I do, and again, straight away, what it's always worth doing is if you look at the marks on there. So I've put the actual mark scheme in here for the answers here, but if you actually have a look at how many marks there are, this is a really, really useful way of like knowing how many steps I'm going to do here. Again, this is a prime example where it says, is his mean time to row 10 kilometers less than 50 minutes? So it's already told me I need to find a mean. But it also says there, show a check of your working. They do like asking you to do a check in regards to the mean. That does happen quite frequently. But this is more the idea of how they've asked it. Sometimes there's a separate box, as we've seen, and it says, use an estimate to check or do a check of your workings. Sometimes it is in the same box though, and what they'll expect is for you in the working out space to do the working out and then write answer check and then prove it after. So I'll give you guys a minute then to have a look at this one. Again, do use a calculator, it makes it a bit easier. And then pop me over some answers when you got them. Mark, absolutely awesome. That one's yeah, that answer's spot on. I think it's like, oh really? Have you got any idea how you could check the answer?
No, I don't actually. That's what I struggle with sometimes.
That's all good. Well, the nice thing is where it says show a check of your working, because it's worded in that way, there are 2 ways that you can check your answer. So you can either use what's called a reverse calculation or an inverse calculation. So you basically just do all of the sums, but do them backwards.
Okay.
Or alternatively, you can use an estimate in this case as well. So you could round a few of the numbers off and then you'll get an answer close to your answer. You might say, well, 54, call that 50, 50. Essentially, you could just call them all 50 or 40 and then do the same sum.
Yeah. Okay.
Yeah, brilliant. So Claire, that's spot on, and Jackie, I'm liking that. So you've kind of given yours to like the nearest minute as well. Absolutely fine, no problems with that. So if I show you how they've kind of worded this in regards to how the actual mark scheme works for this. Oh, I'm liking that, Claire, as well. Yeah, so that's a really good start on how you check the answer as well. So with this one, and this is just to show you, because there are some practice papers on the classroom at the end part. One thing that I will say actually, for yourself, Mark, because I know you might not have been on the classroom for a while, in the very bottom section, in the classroom review, so there are past papers on there and they have the mark scheme, which is obviously going to look similar to this. So you can obviously practice and mark your own things. But also I've put some exam walkthroughs on there. So it's videos that like a learner mentioned to me. I found them, put them on there, but it's like a YouTube video and it's just someone doing pretty much this, putting up a question and then talking through the solution. I think there's a mixture of level 1 and 2 on there. So yeah, really, really useful resource. So in regards to this one, then, so we're gonna get 1 mark for starting to work out the mean. So adding these all together to get a total. And again, you'll see that they have this or, so there's you know, they do accommodate for different ways of how you could potentially solve these problems. So we're then going to find the mean in total. So we've got our 291, and then we're going to divide that by 6. But again, the nice thing, the reason why they put it in those kind of air quotes is to show that even if you add up the numbers and you add them up incorrectly, so you add them and you get 290, you just miscounted, you're still going to get one of the marks for adding numbers and dividing them by 6. Even if it's not the right total, you're still going to get a mark for that, which is really quite nice. So getting the full answer is going to get us to 3 marks, and then the check itself is going to be the 1 mark at the end. So, and again, all it says there, so for a valid check, it's either a reverse calculation or alternative method. So you can use an estimate there as well. What I would say is with these, it's always easiest to work right from the end. So obviously we would have 48.5, or if you've rounded the answer off, you know, 49. So 48.5 multiplied by 6, and that takes us back to our 291. And then I'd say do 291, take away all of the other numbers equals 0. So just go all the way back to the beginning. You don't actually have to do the maths. That's the thing. If you're a bit worried about time, you can just essentially just write, you know, do all of your workings and do them backwards. You'll get the mark for it. Sometimes it is actually useful to do that check though, because it can highlight if you have made an error. It is also, it's a really good thing. The fact that they ask us to do these checks really helps people get used to this idea of how to do sums the other way around. So it helps us like kind of highlight if we need to do multiplication or division a lot of the time. Okay. Oh. You like the mark?
So if you didn't do the work now, would you only actually get 1 point for that then, instead of
on the previous one?
Yeah.
Oh, so what if you just wrote down the answer?
Yeah, if you just wrote down there 4.85, would you only get 1 point for that?
It's an interesting one. I think you would get the marks because it's, you know, there's an infinite amount of numbers. For you to just randomly pull out 48.5,
yeah,
you've obviously worked it out. There's no other way that you'd get to that answer. So, and they are nice. They do tend to obviously give you the marks where they can. The wording of the question can kind of help a little bit with it as well. So there it just says, is his mean time to row 10 kilometers or less than 50? If you were to say, yes, it's 48.5, you'll get all of the marks there. It's always worth, obviously, to get to that point, you would have done the sums anyway. So I would just recommend always writing it down just in case if your answer is wrong. So you've made a slight miscalculation and you've put 48.6 or something like that. If there's no evidence to show those steps that you've done, then they're not going to give you any of the marks, unfortunately. So yeah, definitely worth having a look there though. But again, really, really good question though. I think what we'll do at this point, so we are, what are we at now? 20 past 6. So we'll have a look at this one. We'll make this one the last question for the minute, and then we'll pause and we'll have a bit of a break, which again, we need a break. There's only so much you can do, isn't there? So yeah, we'll take 15 minutes or so, and then we'll carry on looking at these after. So again, this is another exam style question here then. So this is a level 2 question. But again, these are so similar. The level 1 and the level 2 questions are so similar. So the main things with the main difference is they tend to use slightly different numbers, really, slightly harder looking numbers. With these, as soon as you see a sketch or a blueprint of something, what you want to be immediately thinking is, are the units the same? Do I need to switch any units? And also just think, what am I calculating? Am I working out a perimeter, an area, surface area, or a volume? And again, like we've mentioned in the other videos, there are a lot of like subtle hints to that. So sometimes, yeah, if we were working out an area here, it will tend to say, you know, the carpet is, you know, 1 meter squared is this much money. So as soon as you see that, you know you're dealing with an area. I'll give you guys a couple of minutes on this one then to have a look. Again, it is a 4-mark question, and it doesn't say to do a check of your answer. So that tells me that all of the marks here are going to be just for calculating this. I would say this is quite a linear problem, and some of them are, you know, you can just immediately spot that you're going to do it in steps. Sometimes though, it is worth, you know, if it's a 4-mark question, just pause, 4 marks or higher, just pause, read the question, and then bullet point down what you need to do. It just stops you kind of like on the bigger questions, it stops your kind of brain wandering. it stops you worrying about, oh, okay, what's the next step I need to do? It allows you to focus on each specific task that you need to. So I'll give you guys a couple of minutes then and pop me over some answers when you got them. I'm aware people are working through this one. What I'm going to do, just in case anyone is like kind of completely lost or completely stuck, I'm just going to bullet point down the steps that we should follow, and then we'll go through the actual answers in just a second. So with this one being a 4-mark question, I'm just going to read the question and then I'm going to write down the steps that I need to do. So we've got a sketch of the dimensions of the lounge floor and all the corners are right angles. Again, sometimes they do just put extra information there that we don't really need. Let's just, again, testing our ability to take the relevant information out. So the door is 1.25 meters wide. Julia wants to put string lighting in the lounge. So I know that I'm going to be looking for some sort of perimeter because it's around the area. She wants the lights to go all the way around the room and the lights will go above the height of the door. Okay, so it is the perimeter and the door, then that's where the lights are going to go. She wants enough string to cover at least 1.5 times the total distance of the room. Okay, fantastic. So what I need to know what is the perimeter.
14.
Then once I've got the perimeter, I can then say, well, I need the perimeter. I need 1.5 of the perimeter, so 1.5 of the perimeter. And then once I've got that, it's something is 25 meters enough. So although there's only 3 steps kind of written down there, it does kind of keep me on track. And this is, again, it's quite a linear problem. We start from the beginning and start working forward then. Again, in calculating the perimeter, it's these things of like, oh, okay, well, I need to work out what this missing angle at the top is. Okay, cool. So I've got 2 answers there. They're both a little bit different. How are you doing with this one, Mark? You okay? If we...
I think the perimeter is 14.7.
Okay, let's have a look. We'll see how we're doing with it. So in regards to the perimeter, so we should be dealing with, so it's 2 meters along the bottom, and then it's the door, which is 1.25. We've got 3.5 up this wall, 4.7 here, and then we've got the top length as well, which is 3.5. So in total should be 14.7. Is that what you'd said?
Yeah.
Awesome, awesome. So that's already going to get you a couple of the marks there. That's brilliant. What
Tom?
we then... Yep.
So, sorry, you've got
That's
2
okay.
meters at the bottom. You've got a little step up as well. The step up is 1.2 meters, and then it goes along the width of the door.
Ah, of course, yes. Oh, well played, Jackie. Nice one, nice one. Yeah, that's a really, really good question. That's a really good point, actually. Yeah, I'm going to have to change it. No one's ever spotted that either.
Oh.
You are amazing. You should be tutoring me. That's brilliant. Yeah, absolutely brilliant. Yeah, so, and again, it's just to show, like, sometimes you can misread or missee these kind of problems. So I am going to have to kind of rectify that. I don't know if that's in one of the exams or not. I might have to change some Google Classroom resources as well. But essentially, yeah, so what Jackie said there, then we need to know this extra distance as well. So there's this little kind of lip here. We can work that out by 3.5 and obviously 4.7, and it's going to be the difference between them. So in that case, then it should be, so 4.7 take away 3.5. and that's like Jackie said, so that's going to be 1.2. So we actually need to add an additional 1.2 on here. So it should be 15.9, I believe. So I'll make a note of that, and then we can use that moving forward as well. But again, even in this case, if we were going through it, you know, if you've worked out a perimeter, you're going to get some marks for that because you have filled in extra kind of missing bits there. For then doing the perimeter and then finding like a perimeter and a half, essentially. So this answer is going to be a little bit different now. But obviously I've done 14.7 multiplied by 1.5. You can, I'm sure most people would probably look at that and do 14.7 divided by 2 and then add that value on. So that will tell me what the whole perimeter is once and then half of the perimeter as well. Obviously, so for Jackie then, obviously it's a bit of a different answer. So it's 15.9. And we're going to divide that by 2 and then add it onto the original again, so 15.9. So I think, yeah, so the value that you should have then, Jackie, is 23.85, I believe. So you can see there's a little bit of a difference there. But either way, it doesn't actually impact our final answer. So the final answer is that, you know, Julia is correct. 25 meters is more than, you know, I've said 22.05. The actual answer is 23.85. But hopefully you can see where those marks are going to come from as well. So working out the perimeter, I mean, the overall correct answer is going to be one of the marks there. But if you've worked out a perimeter, you know, you've got a potential of getting the mark there. You might not get it though, because obviously we haven't worked it out completely. But for then using the total times it by 1.5, that is definitely going to get us one of the marks. So I think even with our incorrect workings, Mark, we'll still get 2 of the marks there, which is really good. So that's absolutely brilliant. And I'll make a note of that, Jackie. Thank you very much. I can modify that one. I can't believe no one else has ever spotted that either. It's a really interesting one. Like, it's just completely
Didn't even
blindsided.
notice it.
What was that? Sorry.
Didn't even notice it. I think I was so concentrating on what the lengths were that I didn't even spot it at all.
Yeah, I was just like, oh, it's because it says again, like the door is this wide. So I'm like, oh, okay, so it's just that bit there.
In fairness, I look at a lot of plans because I've got a building company.
Okay, fair enough, fair enough. Well, it's good though. Again, it keeps that kind of eye to detail in there. So, but again, it's a perfect example though of just like these, like you're never going to get every single question right, and there will be little kind of mistakes made here and there. It's just, you know, don't beat yourself up too much about them. Okay, so I think at that point then we will take a bit of a break. I'm just going to pause the recording quickly. Okay, so we'll move on then. We'll have a look at our next kind of random question that we've got here then. And just to let you know, obviously, so this is it is a level 1 question, but again, very, very similar. Could be a level 2 question easily. I did ask obviously for some feedback and some ideas in regards to specific topics and content to look at. So I will be including that. Obviously, we are going to be having a look through some past papers potentially later on today if we've got time, but if not, in our next session. But I am aware that obviously one of the ones that was highlighted, I think it was Jackie who had mentioned it, is about the one question about the bike shed, which we will review, don't worry. But it's also about you know, the larger questions that involve these like compound measures as well. So we will review them as well, so don't worry. Have a look at this one then. Let me know how you find it, see if we can get the answer, and we will have a review in just a second. And again, if you do get stuck, just pop me a message or just, you know, air any ideas that you want. It's a nice group. We've only got the 3 of us, which is brilliant, so we can get the most out of it. So do bear in mind as well. I know I mentioned earlier about the time frame for this, but yeah, for each question, it does work out. It's about 1.8 minutes per mark. Obviously, on the smaller questions, we tend to obviously it's a case of do you know it or do you not. So we tend to build up a little bit of time there. But for this question in itself, you have actually got about 7.2 minutes to answer this. So about 7 minutes, 15 seconds. So that's actually a really, really good amount of time for this type of question. How we find it? Does anyone want to kind of volunteer an answer or kind of say where they've got to?
Really?
Not your favourite question, this one, Mark.
No.
No, I've got completely the wrong answer because I've got it's 800 centimeters cubed, which is 8 liters, not. So it's obviously the wrong answer. She thinks it contains 3/4 of a liter.
You are right with the 800 centimeters cubed there. I mean, Mark, did you get to that point as well, or?
Yes, slightly.
Oh, it's actually I've just seen it's 1,000, not 100. Yeah, so I misread that.
Yeah, see, the only time you were wrong is when you thought you were wrong, Jackie, which is lovely. So, yeah, that's
I have
absolutely.
trouble. I have trouble seeing in 3D, so it keeps flattening out. This cube just keeps flattening out, so I'm having really difficulty.
It's difficult sometimes, isn't it, when you look at something and then it kind of, there's some of the shapes where you look at one angle and then it switches almost like the other way around. It's kind of like that Einstein illusion with like the mask where it turns.
Yeah, really
And
odd.
you're like, it's not going to fool me this time, and then it fools you again. You're like, ah. That's great. Yeah, if you've got to the 800 point, then that's most of this question, really. Again, for 4 marks, I always do recommend writing down what we need to know, but this is very straightforward. It's not as wordy as some of the other questions, but the main thing we need to know the volume. We know that because obviously we can see here, and it clearly says. So yeah, things to contain or hold more than this amount. So. So 1,000 centimeters cubed. So we know we're going to be dealing with a volume here then. What we should have then, so first of all, when we work out the volume, we need to work out an area and then multiply it by the depth. So we should end up with 800 centimeters cubed. You'll get that answer. So multiplying all 3 together, you'll get that answer. It doesn't matter which order you multiply them in. But I think, what you are doing essentially, you could do, 5 times 8, which would be 40, and that gives you the area of this side here. And then that side extends for 20 centimeters. It's just remembering it is a prism. It is just a 2D shape. We work out the area and then we just multiply by what we need. So we've got our 800 centimeters cubed. And then all we actually have to do with this one is do a little bit of a conversion. So they've given us a nice kind of scale to use there. This is just one way of looking at this. What you could do is say, well, 3/4 of a liter. If I'm looking at my scale there, well, 1,000 centimeters cubed is 1 liter. So a little bit of a conversion. We know that 3/4 is going to be 0.75. So again, I can use that scale that I've got and I can say, well, that's actually, 750 centimeters cubed then. You can look at it either way. I think most people would kind of look at it like this and you say, well, I've got 800 centimeters cubed. So that will be 0.8 liters. 3/4 of a liter is 0.75. So she is correct, as 0.8 is more than 0.75. But you can prove this in different ways, as I was just saying. I think the thing that tends to throw people is, again, it's adding these extra little bits in there. So with this question, we're using volume and we're also using like a ratio as well, and the fraction. So it's testing quite a few little skills in here. With this, I'd say always, if you're given a ratio and you've got a unit of 1, just look at what is the relationship there. I mean, you can look at it and you can think, okay, well, I've got 1 liter, therefore, if I had 2 liters, that would be 2,000. So half a liter is going to be 500. You can use that to work out where your value goes. But probably the best thing, if you do have a scale and you have, or a ratio, and you get it down to you've got a part that is just 1, just look at the relationship there. So here I've got 1, here it's 1,000. So that means the liter is always, or this value here is always 1,000 times smaller than this number.
So Tom, I worked out that 3/4 of 1,000 was 750, and therefore the 800 was more. Would that be wrong because you've done it at 0.8 and 0.75?
No, absolutely fine. I was just mentioning a minute ago about it. It's either way you prove it. And again, if you see the mark scheme for this question, there will be lots and lots and lots of different ways of proving it. I've chosen to convert my volume into a capacity. But if you've done it the other way, like you have, so you've gone 3/4 of a litre is 0.75. And if you've switched that back to an area, absolutely fine. You're still comparing the two figures. You're still getting them to the same. It's like when we look at our percentages, fractions and decimals. You know, we can convert them however we want, so long as we can, they're all in the same format and we can then compare them.
So the one I had problem with, where it was worded as volume and density, and that's what threw me. See, this one is easy enough, I can understand this, but when it's on about volume and density and whatever it was, that's, I thought, I have
Volume,
no idea. Which
mass
is,
and density, yeah, it's a bit of a nightmare. But
so which part of that is the density? Which part is the volume?
so with this then, so if we were to actually look at it, so we've got a volume, we don't
What's the
know. Yeah,
What's
so
the volume? So I've got, as far as I can see, I've got height, weight, height, width, depth.
yeah, so we've
So
got the height, width, and depth, and we need all of them to find the volume. So the volume is 800
right,
centimeters
okay.
cubed that we worked out. They've given us a conversion to switch this into a capacity, so obviously like liters. So they've given us that conversion. We don't ever have to remember that. They will give you that to work with if you need it. So,
So what's the density?
You couldn't work out the density of this one.
I don't know, because I thought, well, what is the density? I've worked out the figures I needed for this, but I don't know what is the volume, what's the density. I just know that I can work this sum out. When the question says what is the volume or what's the density, I have no idea.
Well, when with questions like this, they tend to ask. The mass is volume times density. So this is the triangle for mass, volume, and density.
But I can't relate that to that cube.
It's because you haven't got enough information, so you can't. It's trying to link something that isn't there at all. It's an interesting. So if we're dealing with, let's say they've given us a mass, because we need two pieces of information to get our answer. So here we've got a volume, we know that, but I have no idea how much this weighs, because I don't know what the things are. I know the dimensions of it, and I could weigh it if I wanted to, but it doesn't tell me how much it weighs at all.
So density is related to weight, is that right?
Yes, yeah. So
right. Okay.
Very much like, so you know when we were talking about speed, so compound measures are a mixture of two measures. Speed is a really easy one to see, and people just work with it all the time without even thinking. So a speed is a distance over time. So if and again, we see it all the time. Yeah, if I'm traveling at 80 miles per hour, I'm traveling a distance in an amount of time. I'm just saying, I'm comparing the two measurements. It's the exact same with density. The density of something is how much weight there is in a certain space.
Because the question I got stuck on was, there was a similar design to that, but they were going to put a metal band around it. Wanted to know how much concrete or something would go in it.
Yes, that's the one. What we can do, because I know that question has been on your mind for a little while, hasn't it? And it has it's been causing some problems. So what we'll do, I'll quickly just share the screen. I'll go onto the Google Classroom. I'll find that question, because it is a good example. You've mentioned it before, and it is a good question to look at in regards to this mass, volume, density. And also it does help us with our kind of calculations of volume as well. So if I stop sharing that at that point, and then we'll have a look at this pesky bike shed, and we'll put that one to rest. So it's got to be done. No, it's one of those questions. It will haunt your dreams.
My brain just can't get it together for it. I don't know why not.
So hopefully, can you all see the classroom now?
Yes.
Yeah. Okay. Cool. Let me just find the assessment then. Okay, and it is on this assessment here. Okay, can you see the form? Has that loaded up for everyone?
Yeah.
Okay, brilliant. Okay, let's have a look at this pesky. There it is.
Ready to question.
Oh, it's horrible, isn't it? Look at it, just sitting there being all questiony. Okay, can you all see that one? Okay.
Yeah.
Yes.
So this one here, then, it is a question that it bugs people so much all the time. So, like I was saying before, it does have I've not seen them give you a question where it doesn't involve them giving you the formula. So for speed problems, we need to remember the speed formula and the speed triangle. So we have to know that speed is distance over time, and whatever way you choose to remember that is absolutely fine. With density, I would recommend remembering the triangle, because like I said before, the triangle itself is 3 formulas in one. By covering something up, you work out one formula. By covering something else, you know another one. Sometimes they might give you the formula I have here, but this is only to work out density. I'd have to rearrange that, and we don't really learn that skill. And if you use these triangles, you don't really need to. So I will put the triangle up there for you quickly, and then I'll give you guys a minute to have a look at this one, because obviously some of us might not have actually looked at this for a little while.
Some of us looked and wish we hadn't.
Mass, volume, and density. You know, so did you want me just to kind of talk through this one, or did people want to have a little bit of a go on their own? Or
For me, I'd like you to talk us through it. I don't know what the others want.
Yeah, I think Mark was that was like a bit of a nod, just like, yeah, I'm happy to listen. Right. Fair. Okay. With this one then, so the main thing that you want to look at straight away is, again, right there, how many marks is it worth? And this is what I'm saying about these questions. Any question that tends to involve a density or a volume or a mass, it's always the link with this. They tend to ask you to work out the volume. So that's where a lot of the marks are going to come from here. So if I have a look at this question then, and I can jot down some ideas. So it's 5 marks. So there's going to be quite a few bits to actually work on there. Claire, no problem. That's absolutely fine. I hope the cat's all right. So with it, so we've got it's 5 marks. So I'm just going to not do the maths. I'm just going to read it. So Nicola wants to put a flat roof on a bike store. The roof will be made of concrete and in the shape of a cuboid shown below. So I know I'm dealing with this cuboid. Nicola wants to put a metal strip along the 2 longest edges, and she knows that the density of concrete is this amount, and the mass of 1 meter of metal strip is 5 kilograms. What is the total mass? So the one thing to deal with here for us at functional skills level 2, mass is weight. It is the exact same. So a mass is just a weight. So kilograms, grams, pounds, whatever it might be. Once you go into science a bit more, there is a difference between weight and mass, dependent on gravity, but we don't look at that. It's just, if you see mass, we know we're dealing with a weight. So I need to know the total mass. Total mass. So I know that my total mass is going to be the mass. Oh God. The mass of the cuboid, spelt wrong, and the mass of the metal. So mass of cuboid plus metal. So I know that those are the 2 things which are going to lead to the total. Going back further then, if I'm going to work out the mass of this, I can never work that out unless I have the other 2 components. It's given me the density, that's fantastic, but it hasn't given me the volume. What it's done instead is it's given me a drawing so I can calculate the volume. So I need to know the volume. Again, like I said before, the best step with this is so we look at it, we know we're dealing with volume. The next step is always, are the units the same? This is a very cheeky question. If we look there, no, they're not. We've got meters, and then I know it's a bit small, but the other one is in centimeters. So I'm going to have to convert my units. If I want to know what I'm converting it to, I can use my actual question to help me with this. So am I going to switch everything to meters, or am I going to switch it to centimeters? The thing that gives it away here is where it says the density of concrete is 2,300 kilograms per meter cubed. So I'm going to convert my units to meters, or to meter cubed.
Oh.
So that's going to be one thing there that's going to impact the answer a little bit. Again, when we go through this, we will be able to see where all of the marks come from and how many you can generate as well. So we're going to have to convert this into a meters cubed. We can then find the volume. And again, this is a prime example. So once I've got the volume, it's given me the density. But if I use this formula here, that doesn't help me much. I know that density is equal to the mass, which we are trying to work out, divided by the volume. that looks horrible. What we'll have to rearrange that formula. The best way to do it is if we remember the formula triangle, it makes it a lot easier. We know that we're looking for a mass. So we're looking for a like a weight. So I want to know the mass. I'm going to cover that part up. My sum is going to be volume times density. That's the great thing. These triangles will rearrange these formulas for you in all three different ways that they can be. So they're very, very useful. So once I've got my volume, I'm going to do volume. Oh, there we go. So volume multiplied by density. And that will give me the mass. So I need to know what that is. And again, with these words as well, it is just density itself is just a mixture of measure. So it is just a case of it's a volume, so a space, and then a weight, and it's combined. So how much does this amount weigh? That's essentially all it is. It's no more complex than that. The more dense something is, the more it weighs.
So I'm now confused really, because I thought you said just now the density was the weight, and now you're saying the mass is the weight.
So the mass is the weight. Yeah. No, you're absolutely fine. No. So mass is always weight. The density is the weight of something in a space. So if I know how much something weighs, let's say like this phone, so I can say, you know, this phone weighs, I don't know, 200 grams or something like that. If I want to know the density of it, then I'm going to measure its dimensions, and then I can say it's 200 grams in this amount of space. I can then use that to scale up or down. So if I'm building something out of these phones for some reason, I know that if I have 50 of them, it will weigh more or less, given on the space of it. Does that help a little bit?
Not really, no.
I like the honesty though. It's brilliant.
Sorry.
No, you're absolutely fine. It's just a case of just remembering it is the weight of something per space. So we'll see it when we look through here a little bit more, hopefully. So the only other part I need to look at here then, so I know I've got to convert my units, I've got to find the volume, then I'm going to use that to find the weight. And then the final bit then, it says about these metal strips as well. So she wants to put a metal strip along the two longest edges. So
that would be 7 meters.
Yes, absolutely. Yeah. So what are the longest edges? Or what is the longest edge? And then we're going to obviously edge times 2. That'll give us our answer there. And then we can actually work out the mass of that because it's already given it to us. So this is the mass of 1 meter of metal is 5 kilograms. So they're telling us that for every meter that you have, that is 5 kilograms.
Why can't they just say the weight of 1 meter is kilograms?
I know it's the thing, isn't it? It's the specific wording of it. It's like when we've looked at things where it says, you know, the word like frequency, things like that. If they just said how many, you'd be fine. But when they say these fancy words, it can throw you a little bit.
Yeah.
So, so the edge times 2, and then we're going to work out the mass of the metal then. So we've got quite a few steps to do. It looks like there's a lot there, but it just means once we've broken it down like this, we can actually see clearly where all these marks are going to come from. So first of all, then I've got to convert these units. I need them all in meters. So my first step is going to be, okay, I'm going to convert these units here. I've got 2 meters, 3.5 meters, and 12 centimeters. If I've got 12 centimeters, that is the same as 0.12 meters. So the reason that is there's 100 centimeters in a meter. So that's going to be obviously where that value there comes from. If I minimize that, I should be able to, there we go. So now we are looking at our volume then. So what is the volume? Well, we can work this out quite nice and straightforward. We're just going to multiply all of these together. So we've got 2 times 3.5 times 0.12, and we've got a volume of 0.84. So that tells you the volume here then is 0.84 meters cubed. So what I want to know now, I want to work out how much does this weigh then? I know the density. So the density is like the weight per meter cubed. The reason I'm kind of working with this, and it's this link between it, is because if the density is 2,300 kilograms per meter cubed, I haven't got exactly 1 meter cubed. I've got 0.84. So my answer is going to be close to it, but not quite. So that's why we kind of have this thing. It helps us with our scales a little bit. So we've got 0.84, and I've got to multiply that by the density, which is 2,300. And that's going to give me the weight or the mass. So that is 1932. How are we doing up to this point? Are we okay? Are we following this all right?
Yeah, I think so. I'm writing it all down.
Hopefully it pops up in the exam. This exact question will be sorted.
I'm hoping it doesn't pop up.
I think you've had enough of it, haven't you? So, okay, so if we look at the next bit, then so the longest edge is 3.5 meters. I can see that immediately. I need 2 of them. So that is going to be 3.5 times 2. So that means in total, I've got 7 meters of metal that I need. I know that every meter of metal weighs 5 kilograms. So overall then, the mass of the metal is going to be 5 times 7, which is 35. Then I just need the combined mass of both of these, and that will give me the total overall mass. So I've got my 1,932, and I've got my 35 as well. So when I add the 35 there, I hope we get the right answer. 1967. So we can see there, if we look here, we've got the correct answer. It looks like a lot, like it is quite a long question. But when we actually break that, if we look at where these marks are coming from, even if, let's say, we didn't spot that conversion at the beginning, we're still going to get a mark for calculating a volume. We're still going to get a mark for working out what the weight is, even if it's not the correct weight.
Where did you get the 35 from?
So
massive metal.
Yeah, is that all right?
Yeah.
There's a lot of stuff in there, isn't there? So
yeah.
Has that helped a little bit? I think for yourself, Jackie, what might be useful is potentially have a look on YouTube and just type in, what is density? Like, how does it work? Because I think all that's missing at the minute is just the correct explanation of it. Is like I've tried to explain it in a couple of different ways, but I don't think I've done I've not used the right wording. So
it's strange why you have this mental block over something, isn't it?
It is weird, but again, it's very, very common. But again, it's a good thing. Like, you'll understand something a lot more, or you can work things out a lot more if you understand why there's a thing that I still remember.
Yeah, that's it. Yeah.
When I was doing like biology before, and when I was doing A-level biology, they just said, when DNA folds, you get either an alpha sheet or a beta helix. And I was like, why? And they were like, you don't need to know that at A-level, not a problem. And that didn't help me at all, because then I couldn't remember it, and I was always like, why is that though? So it was only when I went to university and they actually explained that it's because of hydrogen bonding and all these extra bits. I was like, okay, that makes sense.
That makes sense, yeah.
So having a deeper understanding, but again, it's all it's little things. It's like temperaments as well. So it's, if you know that you need to understand something, then we can look for a solution for it a bit more.
Yeah, thanks for that, Tom.
Yeah, no problem. I know that question's been haunting you. That's the thing. And you're not the only person. There's been other questions, and I've had learners who is, even though we're going through other things, they're still looking at it and they're going, you're listening to other things, but you're still thinking about that question. So
it's still in the back of your mind, isn't it? Yeah.
Yeah, it's a constant thing there. So right, don't worry though, it's all good. Okie dokie. So that should load up again now if I do my screen share. And we'll head back to. So is that all right? So do you understand why that answer is the way it is? Then? Is that
it does make more sense now. Yeah.
And again, it might have just been that before. It's again knowing what to do with certain things is great, but also kind of understand it a little bit more helps. But so long as that's really good, because it's really highlighted the importance of actually. It's really highlighted the importance for us of remembering that formula. You do get given the formulas, but sometimes if you put those numbers in, we don't look at rearranging formulas, and we don't have to do it.
I knew the formula, but I had no idea what the mass and what the density was on this block. Yeah,
it's a very strange measurement. That's why it's again, with speed, we're absolutely fine with it, because it's how we say it in the language. If I've travelled 5 miles in an hour, I'm travelling at 5 miles per hour. That's what I'm doing. With a density, it's the same thing really. It's we have a weight, and then we have how dense it is. Like normally you just say it's straight, you know, like if I was talking about my phone again, like, oh, okay, like the weight of this is, let's say, 200 grams. The density of it would also be like 200 grams because it's in that space. The reason that we'd use it though is obviously if I know what the space of it is, I can then work out other kind of other weights based on that, if that makes sense at all.
Yeah. Yeah.
It's a bit of a strange one. It's just a weird compound measure, to be honest. But forget about that for a minute though. Let's have a look at some fraction stuff. So
Oh, we
here's
might have to go after this one.
yeah, no problem, buddy. That's absolutely fine.
Sorry.
Yeah, it's been quite a long time, isn't it? But it will be recorded. I'll pop the email out to everyone. And again, it's always good to. Did you say you've got an exam coming up soon, Mark?
Yeah, 26.
Okay, cool. Again, all I'd recommend just nipping back on the classroom and looking through. What you can do as well. One of the learners pointed out to me yesterday they were struggling to find like what assessments they've completed and what ones they need to do.
Yes.
What you can do is when you go into the classroom, you click on like the top left, and it will come up. It says like a to-do list.
Yeah.
You click on that and then click on the units completed.
Mm.
And what it will do, it will highlight because every assessment and every worksheet is obviously set to you. But if you scroll down there, you can see the marks that obviously I've returned for you, and you can just go, oh, I haven't done this one yet, or I haven't done this one yet. There's a few newer bits I know because we were on the course together a little while ago, and there's a few bits on there which I've modified. So there's like a non-calculator aspect now. There's a formula, things like that as well.
Excellent. Tom, is there any way when you do the exam, is there any way of seeing what questions actually you got wrong, or is there no way?
It's a bit of a frustrating one. So it used to be that, you know, if you sat the exam, then I think maybe I could actually once it's kind of finished, I could get an exact copy of your work in, and then they would actually release that past paper. They don't do that anymore, which is really annoying. So once you do the assessment, you'll then get you can get a breakdown where basically it will go through, it will say all of the skills, and it will tell you what skills you've got the marks in and what ones you've missed them.
Right, okay.
It is kind of useful, but like when I was talking to Jackie and Claire before, it's meant that when I was planning and designing this course here, obviously I've just looked at that data and it said that, you know, metric measurements, for instance, was something that people needed to look at. In reality, it was just one bad question.
Right, okay.
But you can ask, like, if you do the exam and if for some reason you don't pass, you can ask for an exam breakdown, and that will obviously help you to go, oh, okay, well, I need to work on, let's say, fractions or something. And then you can obviously go to that point or that kind of part of the classroom if needed.
Cool.
So am I right in thinking the resit paper is different to the original one?
So like the paper that you're going to be sitting this time? Yeah. So it's always a different paper.
So if it's different, it might not have the dreaded bike shed.
Yeah, still thinking about it. Yeah, you're absolutely fine. It's so the actual exams themselves are just randomly generated. So they have like a bank of questions, and then when you sit an exam, because obviously you can sit them whenever you want. Really, they just generate a random amount of questions and they send it out. Obviously, they review that every now and then, and they kind of look and they go, oh, well, this question has been causing problems, or we're going to modify this or adapt that, make a new question perhaps. All the resources on the classroom are from past exam papers. So like these questions as well. So they always tend to ask them and word them in the same way, but you won't ever see this exact question. You might see something very similar, but they won't ever duplicate the questions.
Okay, thank you.
I think
You'll have a coal shed instead of a bike shed.
Yeah, it'll be a coal shed or something. But
I think that's half my problem sometimes. It's just the way it's worded.
I have the same trouble. Yeah.
It's a really tough. I mean, in regards to steps to it, I mean, obviously we spoke a little bit about it earlier. The idea of obviously if you have these questions which are 4 to 6 marks, don't do the math straight away. Just bullet point down what you need to do. It is a really, really useful way of keeping you focused on each task. And it also means for some people, they might look at the question and go, I don't know where to start on that. They look at the first bit and then you almost fall at that hurdle. In reality, you might have been able to do step 3, step 4, and step 5.
Yeah.
So it does help with that. The other thing I'd say is use a highlighter. we did kind of like a bit of an experiment in the school I worked in before. So we gave all the students a test to do. They completed it. We then gave them a very, very similar test, testing all the same skills, but we said that before they done the exam or before they were allowed to answer the questions, they could look over the paper, but they only had a highlighter. So they had to just highlight key information for the first 10 minutes. What we found is that every single person improved by at least 5%.
Really?
So it does really help. And hopefully, you know, I've mentioned a few times about the time frames. You know, you have got a lot of time in there. You know, it's 1.8 minutes per mark, but you have got more than enough time. So don't worry about the time frame at all. You know, you can read the question and then you can just highlight the key bits so it stands out. It is always going to be a case of sometimes the wording will throw you a little bit. It is going to happen. We're never going to score 100%. But again, by practicing these types of questions and seeing how they tend to word them can be really, really useful there. Okay, so I think I'll nip through this question now then, because I think, yeah, so Claire's got the answer in there. So thank you very much, Claire. So I'll nip through this one quick, and I'm aware you need to make a move, don't you, Mark? So
yeah.
So for this one here, then, so it's a 3-mark question. So the table shows the amount of money collected by each team for the rowing event. Luke was in Team A, and he says that Team A has collected 1/5 of the total amount. Yeah. This is a nice question because it clearly says that is 1/5 of the total amount this much,
which is 2348.8.
Yeah. So what we can do then, all we're going to do is there's different ways of solving this, and again they've shown that here, but we can add all these together, and we should get 11744. That's our total. If we then divide that by 5, we end up with 2348.8, like Jackie's just said. So then we can use that, and we can say, again, this is really good. So this really shows you where the actual marks here can be very generous. They are really quite nice. So, you know, it's not the exact amount. It's 2348.8. So most people would just say, no, it is not. And that's fine. However, if you say like it's nearly the amount, you know, you don't necessarily have to say no or yes, and they will still give you the mark there, which is really, really nice of them, I think. But I think it's a good point to end on, I think, for yourself, Mark, definitely, because it's just to show, although there are these more horrible looking questions, there are also these questions as well, which are very nice, very straightforward. So we'll move on then. We'll have a look at some other ones and stuff. But again, if you have had enough, as you have, absolutely fine. So thanks for joining us, Mark. I hope it was useful for you. And are you attending the next one at all? Or?
Yeah, I'll be attending the next one.
Cool. We'll see you in that one then. And again, we're just going to be going through past paper examples again, just practicing that stuff. So
excellent.
If there are any certain topics that you want to review in particular, like, I don't know, percentages or something like that, just mention at the beginning. I'll just try and find those types of questions.
Okay, cool.
All good, cool. Take it easy, buddy.
Cheers, bye.
Okay, so for the rest of us, so we've got another question here. It's a 4-mark question. So again, this might be a case of bullet pointing down some information. Again, this is, I do just want to draw attention to that extra little bit there. So, you know, it's a lot of information here. Is Ben correct? Show why you think this. Show a check of your working. So it's included in the same box. Because it says just show a check, that's going to be one of our marks there. So it's only a 3-mark question and 1 for the check. But we can check that with either an estimate or with a reverse calculation, whatever you want to do. So I'll just give you guys a minute to have a look at that, and then we'll go through it together in just a second.
Jackie, I can hear your workings out.
Sorry.
But you've got the same as me so far.
Okay, so I'm going to start going through this one then, if that's all right with everyone. And obviously the point that you're up to is absolutely fine. We can just start kind of going from there. So you've got an answer there, which I'm assuming is going to be the same as Jackie's because you've got the same working out at the beginning, which is brilliant. So no, he's incorrect. Okay, so let's have a look then. We'll see how we've done with it. So although this is a level 1 question, I've put a mixture of them in here just to really kind of demonstrate that they are very, very, very similar. So let's have a look then. So there's a couple of steps here. And again, this just shows you different ways of how you can start to kind of build this answer. So he knows that there's 500 grams of dried rabbit food contains 90 grams of fiber and 30% of the hay is fiber. So Ben thinks that 500 grams of hay has twice as much fiber as 500 grams of the dried rabbit food. So it's just a comparison here. So what we know is that we need to essentially find kind of 30% of 500. That's one thing that we have to do. So you can see at the top there. So we've done 30 divided by 100 times 500, or how we tend to look at this, or how I've normally taught this. We're going to do 500 divided by 100 to find 1 or 1%, or what 1% is. And then I'm going to multiply that by 30. So that's going to give me the total amount there. What I then know is, in this case here, we've got 500 grams of dried rabbit food contains 90 grams of fiber. So we can just kind of continue to build on this, and then hopefully when we get to the end there. So if you've got any of these answers here, then you should be absolutely fine. Just checking there. Yeah, so again, any of these that you've kind of said, and it's good to just kind of show them what the different answers can look like. No, and it's this amount, or no, and this amount. There's lots of different answers for this, but essentially, you know, Ben thinks that 500 grams of hay has twice as much fiber as the dried rabbit food. We know that there's, when we double our 90, it isn't the same. So that's essentially that last step. For the answer check then, again, just to show you how they look at this on the actual exam, it is just a valid check. So we're just doing a reverse calculation or alternative method. What that means is that an estimate will be absolutely fine as well. So there's no problems there. Okay, another random question for you then. So this is, again, straight away, I can see that it's got a ratio involved in it. So I'll give you guys a minute to try and answer this one. So 3 marks. So we're essentially looking for kind of like 2 steps here. It's quite nicely worded as well. So write down the ratio in the form of A to B to C. Give the ratio in its simplest form. So that straight away tells me that writing the ratio is going to get you definitely one of the marks there. But simplifying it is going to be the 2nd mark at least. So it's not actually too long a question, which is quite nice. Just have a minute and then let me know when you've got an answer and we'll go through it together. Okay. Have we got some answers for this one then? Okay, yeah. So Claire, that's it's good that you found the ratio in itself there. Again, simplifying it is again, this one's a little bit of a strange one to simplify, but we will look through it in just a second.
All I could think was obviously to halve each number, but then you end up with a point something.
Yeah, so it's halving it isn't really going to work there. I mean, any other can you think of any other numbers that kind of go into them at all? It is a strange one. I think one thing that helps with it, so if even if you look at the first value that you've got, so you've got 19 as your first value.
Yeah.
Obviously nothing smaller than that. If I'm thinking about 19, I know, I mean, off the top of my head, I know that's a prime number. So it's not in the 2 times table, the 3, the 4, the 5, the 6, or anything. It is only in the only 2 numbers that multiply to make that is 1 and 19. So the only thing I would then look for, I mean, they've already said that, like, to give it in its simplest form. So that tells me it will be able to be simplified. What I would then think is, can I divide them all by 19? Or does 19 fit into all of them? So that would be the last step that I'd go to there. It's good because they have said what is it in the simplest form as well. So I think Jackie's got a little bit of a different answer to you there. So what I'm going to do is going to pop up the workings there, and we'll have a look.
Well, I turned it into percentages and did it that way.
Oh, okay, fair enough.
You're probably thinking, why the hell did you do that?
to each your own. There's different ways of looking at these things. So if we have a look, so Adam offers 3 payment options to car buyers. So the payment options are cash, installments, or on a lease. Adam has sold 114 cars last year, 19 to option A, 57 to option B, and the rest to option C. He's going to write a report, and he needs to show the ratio of the number of cars each payment option as A and C. So it's quite a nice straightforward question. What we have to do is, at first, we need to work out, well, what is option C? And that's just going to be the remainder or the difference. So there was 114 cars in total. If I take away 19 and I take away 57, I'm left with what C is. So C in this case is going to be 38. So I've now got my ratio then, and
I made it 76.
Made it to 76 there.
Well, if you've got 114 to start with, take away 57 and take away 19. Oh yeah, it's 38. Where did I get 76 from?
No idea. It's an interesting one. It happens sometimes. So with this one, so we've ended up with, so we've got our value, we've got 38, and just like I said there, so we've done our one sum, we've then written the ratio, so 19 to 57 to 38. It is a strange looking ratio, and what Claire's kind of started doing there is the best way forward. Look at it and just think, if I'm simplifying it, can I half it? That's the easiest way forward. None of these numbers are, obviously I've got 19, 57, 38, so they're not all even, so I won't be able to half any of them. It's just glancing, kind of seeing, normally if you can't half them, look and see if they end in a 0 or a 5 perhaps, and then it could be divided by 5 or maybe by 10. If that doesn't happen, probably look for the 3 times table as well. If it's not in the 2s, the 3s, or the 5s, then probably the best you can do is potentially just think about dividing by itself. If I do 19 divided by 19, I end up with 1. What I can then see is actually there's 2 19s in 38, and so on. So the simplified ratio of this will go to 1 to 3 to 2. So you can just look at the comparison between them. If part A is 1, there's 2 lots of that, or double that is for part C, and treble it for part B in the middle. So yeah, Claire, absolutely spot on. Yeah, so you simplified it in the end there. It is just an example of, with that type of question, we just need to pay as much attention to it as possible. Again, sometimes we are going to get some of these right, we are going to get some of them wrong. That one's quite a nice ratio question as they go. It's just that simplifying bit at the end, but them stating that does really help to guide us. So let's have another look then, see what else we've got. Oh, lovely. So again, it looks like there's a lot of information in here. So what I would recommend Again, straight away, look there. Okay, it is 5 marks. So there are going to be several steps involved in working this out. So I'll give you guys a couple of minutes on this, and then I'll go through. I'll start jotting down the steps or what we need to consider to actually work out here. Okay, so it's quite an interesting question, this one. Again, a little bit different. It is a formula-based question. So again, there's a couple of things that should stand out there straight away. One of them being the x plus 0.9y. Again, if the number is just next to the letter, or if the letters are just next to each other, that means we are going to multiply them. So do bear that in mind. If I read through the question, there's a lot of information in there. And again, this is an example of where they try to make things as vocational as possible, but sometimes it doesn't actually make all that much sense. But with this then, so she sets the price of the tickets for a new show. She uses this formula to work out the price for a ticket for the seats in the stalls. So the theatre has this many seats in the stalls and this many balcony seats. I need to know both of those values to work out what P is. And in this case, P is the normal price of a ticket in the seats. Okay, so on Monday then, she sells 45 tickets for seats in the stalls to a school, and she charges 60% of the normal ticket price for each seat. So what is the total amount that she is going to charge the school? Again, you can see how people might get a little bit lost here because there's multiple steps there. I just go through and start bullet pointing down what we're going to be doing here. So first of all, I need to know what is the price of a ticket. Nice and straightforward. I'm going to use the formula. I'm going to use that formula. I'm going to put in the information, and I'm going to work out the price of a ticket, or in this case, the price of a ticket. So I'm going to work out the price of a ticket. Once I have that, and again, there's different ways of doing this. I'm going to then say ticket price times 45 because there's 45 of them. Now, it's a bit of a tricky one here. So she's going to charge it. She charges 60% of the normal ticket price. So it's a bit of a difference. You can just find what 60% is, but you could do that in a couple of ways. You could work out 40% and subtract it, or you can just work out what 60% is. So what is 60% total? And then overall, then that's going to be my answer. So there's only really 3 steps here, but each one for actually putting the information into the formula and using that, that's where some of the marks will be here. So these are the steps then. What I'm going to do, I'm going to start revealing the answer, and we'll see how we're doing with that. If that's okay with you guys, obviously. Have you nearly completed this one? Do you want an extra bit of time, or? I
got kind of, I wrote down what the X was and what the Y was and did a bit of a calculation, and that's as far as I got.
Okay, are you happy for me to start going through it? I mean, I think the main thing is looked at it and you've started to think about it and go, okay, I'll probably do this, 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 and this. And then it's nice to see if that's obviously the correct way of viewing it.
I wrote bid mass down as well. Would I get a point for that?
Oh, I don't think you'll get a point for it, but it's good that you can remember it. And again, it's the nice thing though. That's why looking at these past paper questions is so beneficial. As soon as we see a formula, we're thinking, right, make sure I follow the right order. So first of all, then, what we're looking at is so kind of this part of the formula. So I've got like the bottom part of it. So I've got x is 180 plus 0.9 lots of y, which is 70. So I can work that out there. So for putting the information in and completing that first sum is going to get you one of the marks there. So the bottom value there is going to be 243. We then need to have 6,500 divided by that amount.
Yeah, I got that bit.
Fantastic, fantastic. So that's good though. That's 2 marks for that bit there. So if you get into this value here, I just want to quickly check that because it might go. So it's 6,500 divided by 243. So you end up with a non-terminating decimal. So you end up with something that's going to repeat forever because it's got the little dot on there. So you've put here obviously that dot continues. At this point, I would probably, because I know I'm going to be working out with percentages of the value and things like that, you can keep the whole value or you can choose at that point to round it off. I would normally say to keep the whole value or keep a longer value for as long as you can, because obviously if we're then finding percentages or we're increasing that amount, those smaller values are going to have a bit of an impact on the overall amount. That being said, I'm sure there will be an actual variance, or there will be an actual kind of like linking where they'll show a bit of a bit of a range of answers essentially.
Tom, could I very quickly stop you?
Yeah.
I've got written down to 26 point. I just wrote down 7489. So I wouldn't then round it up to 26.75.
You don't have
it
to.
Would
so
make a difference, wouldn't it, at the end? But
it will make a bit of a difference to the end answer, but they are considerate with this. And I believe if we have a quick look, you can see it. So if you just look at that last step there, you can see there's a range of answers that they're happy to accept.
Right. Okay.
So and that will factor in for all of it. So if you do have a scientific calculator and you can hold more of the information on there, then you can do that, and you're going to get a bit of a nicer answer. If not, though, you can round at that point to 2 decimal places, or like you've done, maybe keep it at 3 or 4 places. Absolutely fine.
Okay, thank you.
Oh my. So what they've done here on this next point, then they've taken the value, whatever it might be, and again, everyone's going to have slightly different values. That's absolutely fine. They've done a multiplication of 0.6. So what that is doing is essentially finding what 60% is. So what they're saying is, find out what 60%. So they found out 60% of one ticket, and then they've multiplied that by 45. You can do it the other way. You can find the overall total and then find 60% of that. It's a bit of a shortcut for them finding the percentage. Obviously, we tend to, because I want people to understand exactly what they're doing when we work with percentages, we would do 26.74, etc., divided by 100, multiplied by 60, and that will tell us 60%. Some people you might find 40% and take that away. You might look at it that way. That's absolutely fine. Either way, you get to 60%, not a problem. So then once we've got that value, then we're then going to obviously multiply that by 45, or you can multiply by 45 at the beginning and go the other way with it. But all in all then, and this is a very good example to show you that they are lenient in regards to the type of answer that you're going to get there. So how was that one for everyone? Was that okay? Are we quite happy with that?
Well, I would have been pleased to get 1 or 2 points from what I've done.
Yeah,
that's
definitely.
All I can say.
if you had a bit more time, do you think you would have been happy? I mean, if you put that information in and you'd solved for P and you know what the amount is.
Yeah.
If you had a bit more time.
It would have taken me quite a while to work the rest of it out tonight. So
yeah, well, it's quite a long day, isn't it? Really. So it is just one of those things. At the same time, though, we have got some. It's nice to see these types of questions broken down. That's a 5-mark question, but it's very nice and linear. So you when you do get these bigger questions, they can be nice and straightforward like this. And that is all of the random questions that I've got made there. So that's absolutely brilliant. and my laptop is actually about to die as well. So okie dokie. So I'm just gonna pause that recording again. So what we'll do, if we'll put a pin in it there, so just for the recording's sake, I'm just gonna say that's the end of our session. I recommend kind of nipping along, having a look through the Google Classroom, doing some extra resource. Any extra assessments you can do are going to be useful, but look down at the bottom section on there at the topic overviews. Obviously, we'll get this emailed out to everyone. So if you're watching this, then I hope it's been helpful. And next week we will be looking at more of these practice questions.